Lecture 8 of Basic Electronics is about EMOSFET.
Hello guys, welcome back to our channel ClassFly Community. So today we will be dealing with the construction of the EMOSFET. That means, yes, the enhancement type MOSFET. That means here there will be a positive gate bias voltage which will act as an enhancement MOSFET. So here also we will be taking the N-channel EMOSFET. So let's begin with the picturization. So we brought a picture for the N-channel EMOSFET. Similarly, same thing will be there. P-type substrate will be there, two N-type highly doped will be there, one metallic plate will be there for the source. Similarly, for the drain also metallic layer will be there so that they can get connected to each other. Similarly, for the gate also will be there, and there will be the SiO2 layer that will be acting as an insulator. The only difference which is there is that there is no channel which is being created. No N channel is being created. That means here this NP and this NP are back to back. They are not connected with any channel. And here the most important thing is that here the gate will always be forward bias, and when the NP N substrate is working, that means source NP is working, that this point will be at that time forward bias and the other drain substrate will be in the reverse bias position. So the 2 points which are stated that the construction of an N-channel EMOSFET we are doing, the main difference between the construction of the MOSFET and the EMOSFET, as we see from the figures given below, that the EMOSFET substrate extends all the way to the silicon oxide and no channels are doped between the source and the drain. Channels are electrically induced in this MOSFET. That means channel will electrically get induced in this MOSFET when a positive gate source voltage is applied. So whenever we will apply this positive gate source here, at that point of time, it will already get electrically induced automatically. Okay. So let's move on to the construction we have done. So let's move on to the working. So, or you can say the operation. So this is the picture which is given and there are many points which are being written. So before that, let's give me a brief thing with the picturization, that first of all, like similar like the MOSFET, here also we will give drain and the source the supply. So at that time it will be positive and the negative. At that time a current will flow which will be the drain current. Then the gate will be not given. But here when we supply the gate, at this point of time there is a positive charge here which gets occurred. So here also we will have some positive charge, and due to that it will attract the negative charge, and what happens, it will create an inversion layer as we increase the positive charge in this gate. So at that point of time what happens, when we more and more positive charge is given to this gate, this induced in channel gets happen, and that is being only said that it electrically induces the channel. So let's read point wise and get brief intro or the brief operation of an EMOSFET in a detailed manner. So as its name says, this MOSFET operates only in the enhancement mode. So there is only one enhancement mode and there is no depletion mode, and it operates with large positive gate voltage only. So this is the gate voltage which is being given with the supply, that means with the source, and this is a very high positive one. Positive gate voltage will be given. It does not conduct when the gate source voltage VGS is equal to. When this VGS will be equal to 0, this states that it is off. Okay, and that is the reason it is normally called that it is normally off MOSFET. In this MOSFET, drain current ID flows when VGS exceeds VGST. Now, what is VGST? Gate to source threshold voltage. When it starts creating this induced current, at the point it starts creating, that is called the voltage threshold. Okay. So when this VGS, that means gate source voltage, increases or exceeds that threshold voltage, at that point of time, drain current starts flowing. So when the gate is made positive with respect to the source and the substrate, that means this is positive, and with this substrate negative, that is minority charge carriers within the substrate are attracted to the positive gate, accumulate close to the surface of the substrate. So it will that the negative charge carriers, what happens? The negative charge carriers will start getting attracted to the positive gate substrate and it will start accumulating at the surface of the substrate. As the gate voltage is increased, more and more electrons accumulate under the gate. Now since this electron cannot flow across the insulated layer of the silicon dioxide to the gate, so they accumulate at the surface of the substrate. As this is acts as an insulator, so this charge can't go beyond this, so it starts accumulating here only. Okay. So now this accumulated minority charge carriers N-type channels stretching from drain to source. That means this minority charge which gets accumulated here, these are making an induced channel between this drain to source. When this occurs, a channel is induced by forming what is termed as inversion layer. So this is known as now your inversion layer. Now a drain current starts flowing. Now a drain current will start flowing and the strength of the drain current will depend on the channel's resistance, which in turn depends upon the number of charges get attracted to this positive gate. Thus, drain current is controlled by this gate's potential. Since the conductivity of this channel is enhanced by the positive bias on the gate, so this basically see when this gate is positive and the source is negative, at that time it is working as the enhancement mode. That's why it is EMOSFET. So forget everything. The main concept is that whenever this induced channel will get accumulated, that means the positive gate will starts accumulating this negative charge carriers. At that point of time, the drain current will flow, and this drain current depend on its gate potential. As long as this will start accumulating, till that point of time, this drain current will start flowing. So the minimum value of this gate to source voltage that is required to form this inversion is termed to be gate to source threshold voltage. I told you, so when this induced N channel starts creating, at that point of time, at that minimum value will be the threshold voltage. So when this VGS will be more at that point of time, more than this VGST, at that point of time the drain current will flow. Now see, for VGS, below VGST, the drain current, its ID is equal to 0. That means when this VGS will be less than this VGST, at that point of time, this drain current will be 0. But for VGS exceeding this VGST, an N-type inversion layer connects to the source to drain and the drain current ID is large. So, just the opposite is happening. So, depending upon the device being used, VGST may vary from 1 volt. So, the VGST can vary from 1 volt to 5 volt. It depends on the device which is being used. So, JFET and DMOSFET are classified as the depletion mode device because the conductivity depends on the action of the depletion layer. So, they are called the depletion mode device because their conductivity depends on the depletion layer, whereas the EMOSFET is considered as the enhancement mode device because its conductivity depends on the enhancement or the inversion layer, you can see. So, see, the depletion mode devices are normally on when the VGS is 0, but it is just the opposite when the enhancement mode device, that means it will be normally off when VGS is equal to 0. So, I have written all these in points so you can relate to the picture very easily. So to just remember main things that VGS will equal to 0 at that point of time, this N channel EMOSFET will be off, but for the DMOSFET it will be on. And at the DMOSFET it is negative and positive, but for the EMOSFET it is positive and negative. There was already a channel which was doped, but here when this positive is occurring, that means the gate channel is becoming more and more positive, this induced channel is getting formed. So I hope you all understood the operation of the EMOSFET and the construction. So today's lecture ends here. See you all next. Till then, be happy and have a great day.
Now is the court time. Revenge proves its own executioner. I hope all of you understood the lecture of today and thank you for watching.
Wow, that's
That's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magaz videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.